Good evening, everyone. Today we are going to learn about the liquid solutions and its colligative properties. That means what types of properties are due to the concentration of different molecules we can have. So we will learn that. So mainly we will learn different types of solutions, and from them we will learn the properties of different types of solutions. First of all, you are familiar with the solution and also mixer. Then what is mixer? Yes, combination of at least two. At least it can have many. Here you can see one example. Complex mixer such as bacterial cell contains more than 5,000 compounds. That means in a bacteria we can have hundreds, or that means there are about 5,000 different types of. So it can have at least, for to be a mixer you should have at least two different components. And if the ratio or everywhere the composition are same, then we can consider as homogeneous mixer. And if the compositions are different, in certain place you may have the composition very high concentration, another position you may have lower concentration. That means if the composition through the all components, through all the area or all the volume, the compositions are different, then we can consider that as heterogeneous mixer. And we can consider homogeneous mixer like as solution. For a solution, you will have all the components. That means in the substance or the mixer, if the composition of the mixers are similar everywhere, in that case we can consider that as solution. So retains same proportions of its components. That means if you have the components everywhere same, in that case we can consider homogeneous mixer. And if you have the homogeneous mixer, we can consider that a kind of solution. So it by composition, what types of composition we may have depending on types of components: solid, liquid, liquid, solid, liquid, or solid, even liquid gas. Based on the different types of components, we can classify our solutions in several categories. In the next slide, we will learn that. First, a solution is a homogeneous mixer. Already I have mentioned that solution is a homogeneous mixer. That means everywhere all the composition should be same. Maybe we can consider an example. If you take a mixer of sand and salt, in that case, that means if you try to mix up just using a blender, in that case we can have very good ratio. That means everywhere the ratio can be very good. So in that case, maybe we can consider that kind of solution. That means homogeneous mixer. But in reality, if you want to mix up some salt and some sand over here or in a pot, and then you try to use your spoon, that cannot give you a very good ratio of the compositions. Therefore, most of the case we consider that the mixture of salt and sand as non-homogeneous or heterogeneous mixture. Therefore, or in another way, if you dissolve some salt into water, so in that case it is very hard to distinguish where the salt is or where the water is in different ratio. So maybe initially when you put a pinch of water, salt in the water, before dissolving you can have the mixers or if you have the ratio different. But when or once the salt is dissolved into water, you will get the taste or salty taste everywhere in the water with same taste or similarly salty, or whatever the how much salty is, you will get everywhere same. So in that case, you cannot distinguish where the compositions are. That means separately you cannot have the compositions. So we can consider that the solution of, we can consider that the mixture of salt and water is a solution, because we cannot distinguish or we cannot separate, or the composition of the solutions are everywhere same, exist as one single phase. That means if you have a solution, in that case it will be just in a single phase. That means if you have salt and water, in that case you cannot distinguish either salt in solid state or the water is in liquid state. It is when it is in solution, everything is in liquid state. That means they are in the same phase. We have given the solid salt. However, when it is in solution, it has, previously we had two different substances, solid salt in solid phase and liquid in liquid phase. So when it is in solution, in that case we will have only one phase. You cannot distinguish both of them. So we have only one phase. Solute plus solvent equals solution, or everyone know. That means to make a solution, you must need a solvent and a solute. So what is solvent and what is solute? Anyone?
The salt is the solute, solvent is the water.
Yeah, example is fine, but if we go for the definition, in that case, the majority of the mixture or in the solution is the solvent. That means if you dissolve something into a high amount of substance, that means in the mixture, which one is the major component? The major component is considered as the solvent and the minor component is considered as solute. It can be solid, liquid or gas, whatever. Both the components can be. That means solvent can be liquid or solid or even gas, or even the solute also can be solid, liquid or even gas. So depending on just amount, based on the amount, which one is major component, that will be considered as solvent, and the minor component is considered as the solute. Solubility, that is the how much. That means if you want to make a solution in any solvent, how much, that means how much it can dissolve completely. That means if you consider, as I have mentioned for the salt and water, maybe if you can dissolve 100 gram of salt in 1 liter, then the solubility should be, that means 100 gram divided into 1 liter. So per liter, how much we can dissolve, that is the solubility. Maximum amount of solute that can be dissolved at a specific temperature and pressure. Why we are considering that specific temperature and pressure? Do you have any idea? Why we have mentioned that the maximum amount of solute that can be dissolved at a specific temperature and pressure?
I think if the temperature is high, it will dissolve more.
Yes. So if you want to define the definition of the solubility, in that case you need to mention the both the temperature and pressure, because if you raise the temperature from the normal, that means if you can maximum amount of solute, I have mentioned, that means maximum amount of solute. What does it mean? That means if you have the maybe you can take 900 ml of water and then you dissolve 100 gram of sodium chloride, that can be the maximum. If you put more 2 or 5 gram of sodium chloride, in that case it cannot dissolve anymore. That means we are trying to make 1 liter solution. So in that means in 1 liter, how much solute can be dissolved? Maximum I have mentioned that 100 gram. So if you give few more grams, 5 or 10 grams, okay, if you can give few more grams, in that case you cannot dissolve anymore. But if you increase the temperature of that solution, in that case you can dissolve little bit more. Later we will see why we can have that. If you increase the temperature, then you can dissolve more amount of solutes. That we'll discuss later. So one very important thing, you are familiar with this, like dissolves like. What does it mean? You are not familiar? Okay, then I think you are familiar with another way. I'm sure you are familiar with this term. That means if you you can dissolve salt into water, but you cannot dissolve yes, or you cannot dissolve water into oil. So that is you know the reason, is it? Why you cannot dissolve oil, or why you cannot mix up oil and water?
Because water has this capacity to bond with the mass inside, but then it doesn't go to oil.
Yeah, but that can be explained in another, using another term, polarity. That means if you are familiar with the word polarity, that means if a molecule is polar, that means if a solute is polar and the solvent is polar, then they can be dissolved very easily. But if the solvent is polar and the solute is non-polar, that means if you take kerosene and diesel, you can easily mix up, because kerosene and diesel both are non-polar. But if you take kerosene and you want to dissolve into water, that cannot be, because kerosene is a non-polar solvent and water is also, water is a polar solvent. So that means if the solvent and solute both are in same state, that means like dissolve. What I have I have mentioned that like dissolves like. That means if the solvent is polar and the solute is polar, in that case you can easily dissolve it. And if the opposite, one is polar, another is non-polar, in that case you cannot dissolve. So sodium chloride is a highly polar compound, that means ionic compound. Is it ionic compound? And water is a polar compound. That means it has very high polarity. Therefore, you can easily consider that sodium chloride can be dissolved into water, but not the methane gas or any kerosene oil, because kerosene is a non-polar compound. That means just if we write down like this way, C17 or then H36, something like this. That can be the formula for kerosene, something like this. So this is a hydrocarbon. All the hydrocarbons are non-polar. Is it methane, ethane, propane, whatever we consider? So this is also a hydrocarbon. So hydrocarbons are non-polar, therefore they cannot be dissolved into polar solvent. So that means like dissolves like. Okay. Intermolecular forces in solutions. That means we can have different types of attraction force between the molecules. So depending on what types of molecules we have. So ion dipole, that means salt in water. So ion dipole, water, salt, that means we have, if I take out this one, hear me? Those who are online? Okay, so I need
Yes,
to
Professor.
increase the voice because, oh, sorry. Because if I connect the, oh, still it is giving. Fine. Okay. Ion dipole, that means salt in water. This is one example. That means salt. For any salt, we have two different types of ions, like as sodium chloride or potassium chloride, whatever we can consider. So, in case of sodium chloride, we may have Na plus and Cl minus, like this, sodium plus and chloride minus. So, ion dipole. These are ions. This is positive ion and this is negative ion. And then water also a polar molecule. Is it? So that means dipolar. If you have something, that means let me write down this is not nice. We have lot of markers, but this is not over. Okay, in that case, I need to go to my. So we have sodium plus and chloride minus and oxygen and hydrogen. This is partially negative, this is partially positive, this is partially negative, this is partially positive. So these are partially negative, partially positive. This is polar. Is it? If you have the water molecule, then we can have the partial positive, partial negative. That means dipole. This is one pole, this is another pole. That means if you consider for Earth, we can consider this is North Pole, South Pole. Here we have the one pole, negative pole, this is one positive pole. That means we can consider the water as a dipole. That means we have the positive pole, negative pole, or negative pole, positive pole, whatever we consider. That means this is dipole. So interaction between intermolecular forces in solution. That means if you have ion and dipole, in that case we can have some one type of interaction. So that is called ion dipole. If you have the interaction between ions and dipoles, then we will consider or we will call it ion dipole interaction. Okay. Then hydrogen bonding. Hydrogen bonding, that means if you have a hydrogen atom, hydrogen bonding, you are familiar with the how we can generate the hydrogen bonding with water molecule or any other molecule also. So if you have another water molecule, in that case we will have maybe oxygen like this, and this is hydrogen, this is another hydrogen. So this is partial positive, this is partial negative, this is partial positive, this is partial negative. In that case, this hydrogen and this oxygen, they can have attraction. So if the attraction force between the hydrogen and oppositely or sorry negatively charged any other component, in that case definitely you must need to have hydrogen to form hydrogen bonding. Without hydrogen you cannot have the hydrogen bonding. So you must to have the hydrogen, that means the attraction between the hydrogen and any other negatively charged atom, that means that it should be very weak. The weak interaction between hydrogen and some other negatively charged particle or component or atom, that is known as hydrogen bond. Okay. Then dipole. That means if you have two dipolar molecule, that means maybe we can consider even that was also okay. Dipole. Polar organic compounds such as chloroform. Okay. You are familiar with the chloroform? What is the formula for chloroform? CCl4 carbon tetrachloride. Yes. Carbon tetrachloride and then CaCl3 chloroform. Okay. And this, like this. No, the CH3, this is methyl chloride. That should be other one. Yeah, that should be. 3Cl and hydrogen should drop. This one hydrogen and this 3Cl. So this is the chloroform. So here you can see that it has partial positive, partial negative, partial negative, partial negative. So if you have this types of molecule, so and another chloroform molecule, in that case we can have some interaction between, if we write down like this way, this is hydrogen and carbon, chlorine. So maybe this is partial positive and this is partial negative. So in that case, we can have the interaction between this molecule and this molecule. That can be very low interaction. That means based on what types of molecule or what are the compositions we have, we can have different types of interactions, and that would be very weak attractions. So sometimes ion induced dipole, iron 2 in hemoglobin and oxygen molecule in blood. So later we'll see some complex compounds, how it can form. So later we'll learn about the ion induced dipole, then dipole induced dipole. Okay, that is little bit complicated, but non-polar molecules. That means this molecule or even hydrogen molecule, what do you think? They should be polar or non-polar? Polar. Okay. Try to explain why. If you write down the structure, oxygen, like this is it, or hydrogen. That means electron here it has one electron, so electrons are shared like this, is it? For oxygen, it should have two electrons, so it can share two electrons like this way. Okay, then how do you can consider that can be polar? You can be wrong, no problem. Just what you are thinking, just I want to know. Okay, for a compound to be polar, you must need to have some polarity. That means how the polarity is created? If the electronegativity is different. Yes. Now, if you have oxygen, nitrogen, hydrogen, in that case, simply you can consider in case of hydrogen, oxygen, that is polar molecule. You have discussed. That means how do you can count that water molecule is polar? More electronegativity. That means it has the electronegativity around 3.5. It has 2.1. Actually, what does it mean? When these shared electrons are when the covalent bond is formed in between hydrogen and oxygen and hydrogen, the shared electron is taken closely, more attraction. That means this shared electron should not stay here. Normally, it should not stay in between exactly or in the middle. Actually, it resides somewhere close to the oxygen. That means these shared electrons are most of the time it is found close to oxygen and little bit far away from the hydrogen. So that means this hydrogen has less availability of that electron. Therefore, we can consider that the deficiency of electron, which is denoted by partial positive, and there are some more electron compared to neutral states. So we can write down this is as minus or partial negative. Now, what about this or this or this? Non-polar. Sure? Yes, non-polar. Because when this hydrogen is bonding, this hydrogen, it has one electron, and this another hydrogen, this has one electron. So both of them are having same electronegativity, 2.1. So they should have the electron in such a way that they share equally. Yes. Therefore, there is no polarity. That means any molecule is formed by similar atoms. That means if you have the hydrogen, nitrogen, oxygen, or even fluorine, whatever, even fluorine is very high in electronegativity. The highest one. But if you write down like this, it is non-polar. No. Because cancel out each other. Is it? So any molecule made of same component or similar atom or same atom, in that case we will have that that molecule will be non-polar. Okay. So dipole, induced dipole, non-polar molecules such as oxygen, nitrogen in water. So if you have these types of molecules, non-polar molecules in water, in that case, it is attracted towards the water very lightly, because we know that light dissolves light. So this is non-polar. So if this is put into a water molecule or inside water molecules, in that case, it will be attracted very lessly or almost nothing. Because if you have already we have mentioned that kerosene or diesel cannot be dissolved into water. But have you ever tried to throw some kerosene inside water, and after that you can take most of the kerosene, just because the kerosene or the whatever the oil, any oil, it will be floating above the water. So you can take out the oils. However, you cannot take out 100%. Still, some of the you can feel the smell of the kerosene or for diesel. So what does it mean? If it didn't have any attractions, in that case, you should be able to remove 100%. It has very less attraction. Still, it has something. So that can be explained like this: non-polar to dipolar. That means what I have mentioned: dipole induced dipole. Okay. Then dispersion forces. Solutions of non-polar substances, petroleum and gasoline. That means solutions of non-polar substances, petroleum and gasolines. So that can be non-polar substances. That can be quite good because the attraction force between two non-polars, actually they don't attract each other. So there will be also very less attraction, not very high attraction, like as polar molecules. So, like as inert gas, if you have some inert gas, what happens? They do not attract each other or even themselves. So, something like this, if you have solutions of non-polar substances, so none of them attract each other. That means they do not form very high interaction or with very high attraction forces. So there will be dispersion forces. Liquid solutions. Physical state of solvent determines the state of the solution. That means we will learn that as already I have mentioned just the first slide or during discussing the first slide. That means what types of component we will use to make the solution. We can classify the solutions in several categories: liquid, solid, solid, liquid, gas, liquid. That means if one of the component is liquid, and we can have other component liquid, other component can be solid or even gas. So as this chapter is directly related to the liquid solutions, so we'll focus mainly with the liquid. So we may have other components. One component is common, that should be liquid. Another component we will consider it can be liquid or solid or gas. So physical state of a solvent determines the state of the solution. That means solvent is the major component. Is it? As already I mentioned that solvent is the, in a solution, solvent is the major component. That means if you want to make a syrup or if you want to make the drink or some juice, let us consider. So we can have that much of water and some lemon juice and few or just a small amount of salt. So you get maybe 2 grams of salt. So you have maybe 250 ml of water. So 2 grams in terms of 250 ml, this is very small. That means we are considering that water is our solvent. So if you have whatever the property of the solvent, that means the phase, that means the either in liquid or solid or gas, whatever the phase of the solvent, that will determine the phase of the solution. Because if you dissolve this 2 grams of salt, do you think it will turn into gas or into vapor or solid? It should not, because we can have just, we have a lot of solvent. That means the major component of the solution is solvent, and the physical property of the solution will be determined by the phase of the solvent. So just physical state of the solvent determines the state of the solution. Then liquid, 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 solid, gas, solid. Non-polar substances dissolve in non-polar solvents, since the dispersion forces can be replaced easily and cannot replace stronger polar interactions. Okay, so if you have liquid, liquid, that means if you want to make the juice, sometime you can have high concentrated mango juice, maybe around 30-40%. Even in Korea I have found maybe 100%. 100%, that means they do not add any water. Depending on the percentage, the cost of the juice is quite different. So if you have 100% mango juice, that would be very sweet, no water. Some people do not like to have so sweet. So what they do, they take just maybe 1/3 mango juice and then dissolve more water. Okay, that means if you want to dissolve that mango juice into water, solute is liquid and solvent is liquid. So you can have liquid solution. Okay. Solid liquid, already we have mentioned that we can have solid, that means salt and water. We can have solid liquid solution. Gas liquid, that can be, you can pass different types of gas. Maybe you can consider when you drink the Sprite, 7-Up, everywhere we have some carbon dioxide. Okay, so that is also a mixture of gas liquid. So you can have that type of example. Sure, this one. Okay, dispersion forces can be replaced. Non-polar substances dissolve in non-polar solvents since the dispersion force can be replaced easily. That means dispersion force, what we have mentioned here, solutions of non-polar substances, petroleum and gasoline. So if you have a gasoline or petroleum, that are non-polar. Okay, so non-polar molecule, gasoline, and we are considering the petroleum. It do not attract the molecules at all. That means disperse, it can replace, as there is no attraction force. Whatever we mentioned, that the gasoline and another one, and non-polar substance, another solutions of non-polar substance, petroleum and gasoline. So petroleum, both are non-polar, so they do not attract each other. So one can replace, if you, as there is no attraction between this molecule to this molecule, or even this molecule to other molecule, other gasoline molecule, so one can replace, displace, you can say displace or dispersion. So one can disperse or replace another molecule easily. So that can be considered as dispersion force, because it has no attraction between these two. In that case, one can replace another one. Just if you push, or if you just have any way, if you give the pressure or if you change the temperature, whatever, just it can go randomly anywhere. So it can disperse, or it can replace another molecule. Okay, then so non-polar substance dissolve in non-polar solvent since the dispersion force can be replaced easily. So these types of they have no interaction or attraction. Therefore, it can be replaced, one molecule it can be replaced by other. So easily it can be replaced. So non-polar substance dissolve in non-polar solvent since the dispersion force can be replaced easily. Cannot, and then now we will see the effect of temperature and pressure and on solubility. So how the solubility changes with temperature, or why the solubility changes with or increases with temperature? Because if you have, as already I have mentioned, that if you want to dissolve 100 gram of salt in a sufficient, or 1 liter, maybe you can take a container. You want to dissolve up to this much of water, and you are adding first. Initially, you wanted to add. You have taken this much water, and then you are dissolving salt just one spoon, and then try to mix up, and then at certain point you will see that no more salt can be dissolved. So that is the solubility, where no more salt can be dissolved into the solvent. That is the solubility. That means maximum amount of solvent, maximum amount of solute can be dissolved into the solvent. Okay, at certain temperature and pressure. Now, if you want to, so let us consider we can dissolve 100 gram of salt. Okay, we can dissolve 100 gram of salt into this mass of water. Okay, now solubility. Then what would be happening here? If you have more, you can take 110 gram of salt. In that case, you will have just 10 gram left. It cannot be dissolved at all. Now, if you increase the temperature of this solution, in that case, what will happen? The molecules, all the molecules, gas molecules and the solid molecules, not gas, the solvent molecules and the solid molecules, they will have more kinetic energy. So they can be moved faster. So in that case, the molecules can have more kinetic energy and they can move even faster. Therefore, at higher temperature, the movement of the molecules increases. Therefore, we can consider that the solubility of that molecules will be increased. Okay, so that means at higher temperature, the solubility of that substance. So at that temperature, you can add even more, because if you increase the temperature even higher, maybe you can rise around 20 degrees Celsius. Maybe 20 degrees Celsius, if you increase, in that case you can dissolve more 10 gram. If you increase 50 degrees Celsius, you can maybe add another 10 gram, like this. So at higher temperature, the solubility of the solvent increases, so that we can dissolve more some solute into the water or solvent. Gas solubility decreases. Okay, that is another thing, that if you have the gas molecules, in that case, at higher temperature, solubility increases with increased temperature, gas solubility decreases. That means if you have some gas, in that case, when we want to, if we have gas particles are at equilibrium when saturated solution is formed. Okay, so gas solubility decreases if we have the liquid and gas. In that case, what will happen? Here we have the liquid and you will have some gas here, because just it should be a closed container. If you have the closed container, and in that case, if you increase the pressure, if you increase the temperature of the gas, that means the solvent overall or the total system, in that case, the pressure of the gas will increase. Okay, as the pressure of the gas increases, in that case, the pressure will, the volume is fixed. Is it? As it is a closed container, so the volume is fixed. Therefore, we cannot have the molecules just from here. Some of the molecules will go up, because as we are increasing the temperature, so some of the molecules from the liquid will increase. Therefore, the possibility of having the molecules of the gas molecules coming toward the liquid will decrease, because as we are heating, the more molecules from here will go to the gas it will increase the concentration of the gas molecules. Therefore, we can say that the amount of the solvent is decreasing. Therefore, the solubility of gas will decrease. It will confusing?
Yes.
Okay. So I could understand. So if we increase the temperature, for this solution, in that case, what will happen? Just if you keep certain amount of water in any container, that means it will try to just, if it is not closed, if you put water in a pot for a couple of days or maybe a couple of weeks, in that case it can automatically evaporate. Okay, so what happens there? Some of the water molecule is going to vapor. It is forming vapor. That means it is, so now if you give some heat to the liquid, the evaporation or vaporization will increase. Therefore, more molecules will go up. So if this is closed container, in that case, what will happen? So here you will have more gas molecules. In that case, so these gas molecules already what we have, so it is taking more space. That means the pressure is increasing. Therefore, it do not have the tendency to come to the liquid. Even from liquid, some molecules is escaping. Is it? Some molecules is escaping from the liquid. Therefore, these gas molecules, what we had previously, these gas molecules do not have the tendency to mix up with the liquid. In that case, the density, sorry, the solubility of gases decreases. Gas particles are at an equilibrium when a saturated solution is formed. Okay, that is very interesting thing. So the gas particles are at an equilibrium when saturated solution is formed. That means if you have a mixture, so if you have a solution, that means saturated solution. What does it mean? That means homogeneous. Homogeneous, saturated, everywhere the compositions are same. Okay. In that case, if you have some saturated solution with some salt and the other things, in that case, it can be open or closed, no problem. But in that case, what will happen? No, I think I should mention as closed container. Otherwise, it cannot be in equilibrium. Okay, so let us consider this is closed. Okay, this is completely closed. Now, at constant, that means at saturated state, the physical state will be determined by the solvent. That means what is the major component? If it is liquid, in that case, the total solution will be liquid. And as already I have mentioned, if you put any liquid into the environment, that means it will try to escape few molecules from the surface. Is it? That is called evaporation. Okay. So if you consider this solution is in liquid phase. Okay. This is in liquid phase because we are mixing some salt and water. Salt plus water. So ultimately we can expect the solution would be in liquid phase. Okay. So now gas particles are at equilibrium. So where comes from the gas? Where the gas comes from? We are considering that the solution is in liquid phase. Okay. So any substance, what you keep in the environment or wherever, some of the molecules will, it will take little longer time, however, but some of the molecules from the surface will try to escape always. However, just whatever the temperature, inside room temperature, in the little bit higher temperature, whatever. So at any temperature, the some of the molecules from the surface, not from the inside, just from the surface, some of the molecules will try to escape, because you are familiar with the surface tension. Surface tension, you are familiar. So in that case, here we have a molecule. This molecule have attraction between all other molecules. Is it? Okay. So, but if you consider one molecule at the surface, at the top, in that case, it will have the attraction only towards below. It do not have attraction in the upper side. That means if you consider the level of water just this, so the attraction force between to the molecules which are below of the surface, they have the attraction only in one side. But the molecules, it do not have attraction towards the up. Okay. In that case, the molecules can have, that means the attraction to this molecule is higher compared to this. Is it? This molecule has attraction towards all the molecules nearby, because if you consider, it has surrounding, there are many molecules. But if you consider here some molecule in the top, in that case, it has attraction only. Here we have no. Is it? In that case, this molecule is attracted with high attraction, but this one not. Therefore, this molecule has the possibility to escape from the surface. Is it? Okay. They can go up. Okay. So if the molecule is inside, they are attracted with many other molecules. Therefore, these molecules cannot go out or it cannot escape. But if the molecules in the surface, then they have very low attraction to the molecules, because they have only one side, or that means upside there is no attraction. So this molecule can go up. So what will happen? How they will go up? That means as the attraction for this molecule is very less, therefore it will go into the open space. That means where there is no liquid. So within certain period of time, you will have lot of molecules here. That means evaporation. By evaporation process, here you will have many molecules. Now, then why we are not having the volume of the container is decreasing? Because if you have kept the closed container for a long period of time, in that case, what will happen? As this is closed container, so when this molecule goes close to the surface, that means the lid. If the molecules go to the lid, in that case, it will get connected to or it will reside on the lid, and then after many molecules come close together, then they try to just reduce the temperature. That means they become again liquid. So from surface they are going to the open space as a gas, and then again after a certain period of time, some of the molecules are coming back. So some of the molecules coming back, and this process is continuing. So in that case, we can consider that is So how many molecules are coming back and how many molecules are coming as a gas that are almost same? Therefore, we can consider as equilibrium. So how many molecules is converting into gas and how many molecules is converting into liquid are almost same. Therefore, they are in chemical, sorry, not chemical, they are in equilibrium. So that means you may consider that none of the molecules are going back or none of the molecules are going to be converted to gas. That means what is the characteristics of in equilibrium? In chemical equilibrium, you are considering that it seems to be no reaction actually, but there are some reaction because in chemical equilibrium the forward reaction and backward reaction rate are same. Therefore, here also this is kind of forward reaction, this is kind of backward reaction. So the position where the number of molecules what is converting into gas and the number of molecules what is converting into liquid are in equilibrium. So gas particles are at in equilibrium when saturated solution is formed. Therefore, when this saturated solution is formed, that time the gas particles here are in equilibrium. Okay. Okay. Higher pressure cause more collision, disturb the equilibrium. Okay. In that case, if you increase the pressure for any system, so if you increase the pressure, in that case, the molecules will collide very fast. That means in terms of energy, or if we consider like as if we increase the temperature, what happens? The molecules have more kinetic energy, therefore they can move faster. Even if you increase the pressure, that also it can have high collision, more faster collision. Therefore, the higher pressure cause more collision, disturb the equilibrium. In that case, the equilibrium. So, if you increase the pressure for this, that means normally pressure will affect the this portion because if you have liquid and gas in container, in that case, if you increase the pressure, it will affect more onto the gas. Because with gas you can compress or the effect of pressure is very high in case of gaseous substances compared to liquid or solid. If you put some pressure, if I put some pressure to this, then I cannot squeeze it. But if I put pressure on this, it can be squeezed quite a lot because this is flexible, this is rigid. And if you consider some gas, maybe if I put like this way, some gas inside my hand, so it can be compressed even more. So for anything, so any gas, if you have the pressure, if you increase the pressure, so here the equilibrium will be disturbed. At higher pressure, the equilibrium will be disturbed. More gas dissolves to re-establish the equilibrium. In that case, so if you increase the pressure, in that case the equilibrium will be disturbed, and in that case more gas will be dissolved so that it can come into equilibrium once again. Okay. Henry's law: the solubility of gas is directly proportional to its partial pressure. Okay. Are you familiar with the partial pressure word? What is partial pressure? Okay, that's not a big issue. That if you do not know, that's fine because you came to here learn. So nothing to be afraid or anything, or don't feel shame at all because you came here to learn. If you know something, in that case, maybe I can skip so that I can get few minutes or few seconds release. But if you do not know, then I can explain. So the solubility, already you know what is solubility. That means how much how much the maximum amount of solute will be dissolved into solvent in certain temperature and pressure. So solubility of a gas, That means how much a gas can be dissolved into anything. It can be in liquid or any other gas. That will be dependent or directly proportional to its partial pressure. Partial pressure means, let us consider here is our container. Now you have two different gases. The volume is maybe, let us consider 2 liter. Here you have oxygen gas and you have carbon dioxide gas. Okay, so you have oxygen gas and carbon dioxide gas. The volume of this container is 2 liter fixed. So now what would be the partial pressure? Partial pressure means if you had only one component in this container, no carbon dioxide, just only one component, how much pressure it would create on the container. So if you have a mixture of gases, in that case, that means if you have two different components, you will have some pressure, but what would be the total pressure? That would be just one component. If you have one component, how much it would create the pressure? Oxygen, if you have only oxygen, it will create some pressure. Let us consider that pressure is represented by P1. And if you have only carbon dioxide, in that case, it will exert another pressure, P2. So the total pressure of this container, if you have oxygen and carbon dioxide both, then what will be the total pressure you want to expect? Just sum of, if you have both the gases, these two. So if you keep both the gases at the same time, in that case, you will expect that the total pressure of the gas or the container would be the sum of these two values. Now, if you consider for a mixture of gases, that means we are considering two gases, then one component, how much pressure creates on the substance? That is the partial pressure. If you have a mixture of gases or solution of gases, whatever you consider, just one component, how much pressure it creates on the substance container, that will be the partial pressure. So if you have only one gas, then there is no matter of partial pressure, that is the total pressure. But if you have a mixture of gases, if you have maybe another component, maybe like nitrogen gas, so if you have nitrogen gas, in that case, maybe you can consider three pressures. So if you have a mixture of gases and how much pressure it creates by one component, that is the partial pressure of that component. So normally we know that the volume of the gas particles is very small. In the last chapter we have learned about the kinetic molecular theory. In the kinetic molecular theory we have mentioned that the volume of gas molecules are very small compared to the space between the molecules. Is it? So that if you can take, therefore you can keep all the gases in the same container. Otherwise, if you consider for liquid or solid, in that case, maybe this is our 2 liter container. That means if you want to take 200 gram of ice, 500 gram of rice, and then 300 gram of sugar. In that case, there will be maybe this is 200 gram of ice and then 500 gram of rice and then another 300 gram of. So in that case, just we cannot mix up, or just maybe we can mix up also, but actually we cannot make a complete solution because all the gases, they do not have any interaction between themselves or any other molecule. Therefore, even the space between the molecules is very large. Maybe this is one molecule, this is another molecule, this is another molecule, this is one. So if you have these types of gas molecules, you can get another molecule here. You can have another molecule here. That means when this carbon dioxide, maybe consider we have the container with full of carbon dioxide. Now you want to take same amount of oxygen gas, you can put in the same container. But for these types of substance, you cannot, because they have constant volume. So they have very high volume, therefore they cannot be replaced by another. But in these types of gas, the size of the molecule is so small compared to the space between, therefore easily we can occupy the whole space of the container with very small or very large amount of gas. Therefore, if any gas remains in the gas mixer, that means if the one component, how much pressure is exerted by the single component is considered as partial pressure. Okay. So our formula is the solubility of a gas is directly proportional to its partial pressure. That means how much the gas will be dissolved is directly proportional to the partial pressure of that gas. So solubility of that gas may be considered as, what is the formula? S gas. S gas is proportional to the partial pressure. That means Kh is the constant. So just to write down the partial pressure of the gas, P gas. So if you want to remove this, just multiply with the constant Kh and then P gas. So solubility of the gas equal Kh multiplied by P gas, or partial pressure of the gas, and Kh is the Henry's constant. That means how much the solute or how much gas can be dissolved is equal to the Henry's constant multiplied by the partial pressure of the gas. Gas and solid solutions. That means if you have gas, all gases are infinitely soluble in one another. We always know, because as already I have shown here, we can put 1 liter of gas in this container, another 1 liter of gas in the one container. So we can keep any amount of gas in any container, but in reality that may not, because for any cylinder, the cooking gas, we have sometimes 2 liter cylinder, 10 liter cylinder, 12 liter cylinder, and sometimes 40 liter cylinder like this, and 10 liter maybe like this. So in that case, we always say that ideal character of gas is just the pressure is very low. But if we consider for the very high pressure gas, that is not the ideal character. So what we discuss, or what the properties we are considering or discussing in this course or in future, we will discuss everything. If we consider something or any gas which is ideal, we will always consider that the concentration of the gas is very low and pressure is very low. Okay. So the molecules are very low and the gas concentration is very low, and also the pressure is very low. Okay, so all gases are infinitesimally soluble, and in one another. That means if you have different types of gas, you can mix up in any ratio. Okay. Gas solid. Gas occupies the space between closely packed particles. Here you can see some picture, or even you can consider if you have some solid molecules. Whatever, this can be with some solid molecules or solid substance. Some gas molecules can come here, or anywhere. So by this way, the gas can occupy the free space, because most of the time we know that the structure of solids are very crystalline. Is it crystalline? What does it mean, crystalline? That means the structure maybe some for any molecule, the structure for crystalline may be sodium chloride. If you write down, you are familiar with the structure of sodium chloride? Hexagonal something, is it? So you write down like this way. So it has some free space or void. That means some open space in between the sodium and chlorine. This can be chlorine and sodium, whatever it is. So the gas particles can come into the free space in between the atoms. So gas occupies the space between closely packed particles. If you have some particles very closely packed, however, the gas particle size of the gas particle is very small. Therefore, they can take the space between the closely packed particles. And solid. All of you are familiar with the gold ornaments, and some of you wear the gold ornaments. But do you know these gold ornaments are not 100% pure gold? Why? No, not really. Yes, and if you have the 100% pure gold, that can be easily break down. And but to make any ornament, you need to make the shape different. So if you want to reform it, in that case, you need to have the characteristics, some little flexibility. So you need to add some brass. Okay, that means solid and solid. Brass also solid and the gold is solid. Therefore, they are mixing these two solids to make a solution, that is solid solution, what we call alloy. So the all the gold ornaments are alloy. That means maybe the composition of the gold is very high. Sometimes we call 24K or 22K. Is it 18, 20, whatever? So 20, 18. So this is the pure. Is it? This is pure, and then as we go down, the amount of brass increases and the percentage of gold decreases. Therefore, that means I'm going to give you the example. That means solid mixture or solution, that is alloy. Microscopically heterogeneous. Okay, solid sample. That means if you want to investigate that the gold ornaments using different very high quality microscope, electron microscope, or any other very high quality instrument, in that case you can identify some of the portions have very high high percentage of gold, some of the portion may have very less percent of gold. That means microscopically heterogeneous. That means by eye we cannot separate, or we cannot say that these are different. But if you use high quality instrument, in that case you can observe that the proportions or the components are different in different regions. Maybe not everywhere the same proportion or ratio. Therefore, microscopically heterogeneous intermetallic compounds and a specific stoichiometry. Yeah, so microscopically it's heterogeneous, but overall, if you consider that the property is quite similar, then a specific stoichiometry. So certain characteristics, the melting temperature or boiling temperature, whatever you can consider. So they have more or less similar or some specific. So today we are going to end here. So if you have any question, yes.
Do we only use that to make gold or else?
I think so, because we can use other things also, but as the color of the brass is matches very well.